So in the last video, we talked about simplifying expressions by combining like terms. And now we're going to look at simplifying expressions using a certain mathematical property, and it's called the distributive property. And what this property allows us to do is when we have a quantity, so two things being added together inside parentheses, which means if we knew the numbers, we would add them first for following order of operations. And that whole quantity is being multiplied by another number. We can actually rewrite it as two products. So instead of the product of the quantity, this plus this, we can actually write it as 6 times this plus 6 times this. And here's why that works. So it's a way of just kind of rearranging and rewriting it. So if I have the problem, I'm just going to make one up. 3 times 2 plus 4. All right, if I have that problem, according to the distributive property, I can rewrite this as 3 times 2 plus 3 times 4. So basically you're taking the number that's being multiplied by the quantity and you're multiplying it by each individual term that's on the inside. Let's see if this holds true. So if I was going to actually figure this problem out, I'm going to take the inside of parentheses first. 2 plus 4 is 6. And then I'm going to multiply the 3 times the 6. So this equals 18. And if I follow this one down here, 3 times 2 is 6. And 3 times 4 is 12. And if I add them together, it's 18. So this is the distributive property. It says that you're allowed to do this. So adding and then multiplying is the same as multiplying both of those terms that you were going to add and then adding it later. So that's the distributive property. It allows us to do this. It says that mathematically these are equivalent. So we can use that to simplify these and get rid of parentheses. So what we're going to do is just like we took the 3 and multiplied it times the 2 separately, multiplied it times the 4 separately, and then we were adding those two quantities, we're going to do the same thing here. And what a lot of students like to do is draw these little arrows showing that the 6 is going to get multiplied times the 4b and the 6 is going to get multiplied times the 7. And you just do it individually and they're going to be separated by a plus, or later on we'll see if there's a negative, then maybe a minus. So to simplify this would mean to basically get rid of parentheses. Right now we kind of have 3 terms, we've got some multiplication, so let's just get this down to something simple like these answers we've had up here. Maybe just 2 terms being added or subtracted. So when I multiply here, 6 times 4b, you're just going to multiply the number times the coefficient. So that's 24b. So the number that you get when you multiply 6 times 4 stays in front of the b, just like the 4. And then 6 times 7 is going to be 42. And this would be my final answer because this cannot be simplified any further, right? We've got 24b plus 42. Neither one of these are a like term, so we're done. This is simplified. Now, if I told you what b was, all you're going to have to do is multiply times 24 and add 42. Whereas up here, if you find out what b is, you got to multiply times 4, you got to add it to 7, and then you got to multiply times 6. So slightly more complicated. This is simpler. So we like this. This is a simplified version. So following the same set of rules, if we go over to 24, we're going to take the 2, and we're going to multiply it times both of these terms. And based on the distributive property, it's going to form an equivalent expression. So 2 times 6n is 12n. Just multiplying the numbers, the n stays with them. And now we have this minus. So that minus kind of goes with the 4, because we could change this to plus negative 4 if we wanted to. So it's 2 times negative 4. So we're going to get a negative 8. So again, you could write plus negative 8. But that's not fully simplified. We don't want to write plus negative 8. Because adding negative 8 is the same as just subtracting 8, and that's simpler. We want the simplest form. So we actually want this just to say 12n minus 8. And just like we talked about before, we can jump straight there. So as soon as you realize you're doing 2 times negative 4 and you're going to get negative 8, you can just write minus 8. That's perfectly fine. 25 is very similar to 23. Okay, we've got a number on the outside of parentheses. Now it's just on the right. And so using the distributive property, we can write this as two products being added together instead of this quantity being multiplied by 2. So we're going to take this outside number and multiply it times both. Now, remember, correct simplified form, the variables are going to be up front. So I could do 2 times 1 and write 2, 2 times 4x and get 8x, but then I'm going to have to flip it and rearrange it so the x is up front. So I might as well start with the x, and then I don't have to do that extra work later. So 2 times 4x is 8x, and 2 times 1 is positive 2. So I write plus 2. And it's done. And again, these are equivalent. Okay, so if I plug a number in, so let's actually do that real quick. Plug a number into this, and plug a number into this, and show that they get the same answer. So let's use 3. So if I was plugging in 3, it'd be 1 plus 4 times 3 times 2. And if I plugged it in here, it's 8 times 3 plus 2. So right off the bat, you tell me, which one do you want to do? And actually, I'm sorry, this should be 8 times 3. We plugged in 3 for x. Which one do you want to do? Do you want to do this one up here, which looks a little complicated, or just 8 times 3 plus 2? This is way simpler, and that's why we do this. When we can simplify some, extremely difficult and multi-step expressions, these eventually are going to be things that we're using to solve for real-life situations. So we don't want something that's a little more complicated. We want something simpler. Okay, that just makes our lives easier. So if I come down here, 8 times 3 is 24, and you add the 2, and I get 26. If I was going to do this one, I start inside parentheses. I'm going to do 4 times 3 is 12, plus the 1 is 13, and times 2. 13 times 2 is also going to be 26. So you'll see that both of these are equal to each other. Okay, but one's a whole lot easier to deal with. Okay, so that's why we like this right here. All right, so let's see what happens now. We're going to have some more minuses and some negatives. So we're going to take this 10 and we're going to multiply it times both of these to get two terms in an expression. So 10 times 4m is 40m. And now I want to consider this a negative 9. If you like writing plus negative 9, that's fine. I just like circling it and just thinking of this as negative 9. So subtracting 9 is like a negative 9. I'm going to do 10 times negative 9. So I'm going to get negative 90. So I could write plus negative 90, but then I'm going to have to fix it. So I'm just going to put minus 90, and I'm done. So that is simplified. So 10 times negative 9 is negative 90, and I just write minus 90. So negatives are like a minus, and positives are like a plus. Makes sense. So 27. I'm taking the 10 that's on the outside and multiplying it times both terms. 10 times negative 2a is negative 20a. I'm going to put the variable up front. And 10 times 1 is just 10, so it's plus 10. Done. 28. Negative 9 times both of these. So negative 9 times negative 9 is positive 81p. And now I'm going to do positive 9 times negative 9. That's negative 81. So I'm going to write that as minus 81. So if we can start making that transition where we're not going to put plus negative 81 and then have to fix it and simplify it again, as soon as you get a negative, just write it as a minus. 29. We got a bunch of different negative numbers here. So it's going to be this negative 8 times negative 9 times negative 4. So all of those minuses and negatives kind of are the same thing. So a negative times a negative is a positive. 72n. So negative 8 times negative 9 is 72. And then negative 8 times negative 4 is positive, so I'm going to put plus 32. Now you tell me, if I'm going to ask you to plug into one of these two expressions, do you want to plug into n and multiply by negative 9 and then subtract 4 and multiply by negative 8? Or do you just want to take n and multiply by 72 and add 32? I mean, it's an obvious answer, right? This is simpler, and that's why we do this. Okay, it makes our lives easier. If this is representing a certain situation, okay, and we want to figure out, well, let's pretend N is for minutes, and this is going to tell me how much money somebody makes, or how fast you're going, or anything. If I want to figure that out for a bunch of different situations, I don't want to have to calculate using this a bunch of times. I want to use this. It's simpler. I can get my answers a lot faster. So that's why we do this. So 30, the last one, we're taking this -2 and multiplying it times both terms. So let's start with the variable. We've talked about if there's an x, there's really a 1 in front of it. So this is -2 times 1, which is just -2. But the x is going to tag along. So this is -2x. So basically, when you multiply a number times an x, they just get connected. So -2 times x is -2x. And now I'm multiplying the -2 times a +3. So a negative times a positive is a -6. So my answer is -6. I need to write -6. And there's my answer. So now we've simplified all of these using the distributive property. Okay, and so combining this with our knowledge from up above, we can simplify a whole bunch of different kinds of expressions. We can combine like terms, so when they have the same variable, we combine them. And if we see something where we've got these parentheses, we can use the distributive property to simplify. So you've got a bunch of tools in your toolbox now.